Hi-yo, neighbors. All right, we're on in Algebra 2. All right, so now we're going to do this. Here we go. We're going to take reverse tabular or long division, and we're going to find the quotient of things like we have been doing. But we are going to concentrate on this x minus 3, okay, on the bottom, and then we're going to see a pattern develop as we do several of these. So we're going to start off with how many x's go into this. X minus 3's go into this. So x goes into x. X squared, it goes x times. Turn around, take the x times x and get x squared. And then x times a minus 3 is minus 3x, which does not belong under the 9, so I'm going to squeeze it in here. Turn around, do keep, change, change. The x squareds are gone. I bring down the 3x, and now I'm going to bring down a minus 9. Okay? Obviously, when I take this and I say what times x gives me 3x, that's going to be a 3, so we'll put that up there, a positive 3. So that gives me 3x. 3 times negative 3 is negative 9. Turn around, keep, change, change, and we have a remainder of 0. So our answer for this quotient is x plus 3. So keep that in mind as we move forward. Alright, now on example B, basically we're going to divide x cubed minus 27. I'll divide by x minus 3. And I've got 1 here plus 1 makes rows, and 3 minus 1 is 2, plus 1 is 3. So I have 3 columns, 2 rows. Bottom, of course, still goes over here, reviewing. Top part comes here, x cubed. There are no x squareds, there are no x's, and then a minus 27. So that all fits in nicely. We know that this first one goes right in the blank here. It's the only thing to come out on the diagonal, so that's x cubed. And what times x here gives me x cubed? Well, that's x squared. Once I know that, I can fill in that column. So x squared times a minus 3 is a minus 3x squared. Okay? Then I ask myself my question, what plus a negative 3x squared gives me none of them? And of course that would be a positive 3x squared, which means I multiply the top here by 3x to get the 3x squared with the column in the row. 3x then times the minus 3 to fill in this spot right here is a minus 9x. What can I do up here then? Of course, what plus and minus negative 9x gives me 0? Of course, that is 9x. So 9x goes here. I already have the x, so that's a plus 9 up here. 9 times that is a minus 27. And everything matches up perfectly. So that's still the scenario. No remainder. Got our solution, and this is what we've got. So now, last time I divided x squared minus 9 by x minus 3. I got something now. I'm doing an x cubed minus 27, and I get this answer. And there is a pattern that has begun. We will discuss it, though, later. Okay, in example C, you're going to see that we're getting even bigger up here. Okay, so once again, if I take my columns and my rows, I've got 4 minus 3, which would be 3, plus 1 is 4. So 4 columns. And my bottom is still a degree of 1 plus 1 is 2. So I still have my x minus 3 here. Outer pieces are going to be x to the 4th. There are no x to the 3rds. There are no x squareds. There are no x's. And finally, there's a minus 81. There is a pattern developing, though, for sure. Do the same thing. What times x gives me x to the 4th right here once I fill that in. And, of course, that's x to the 3rd goes up top. X to the 3rd here times the minus 3 right here goes in here. And that, of course, is a minus 3x to the 3rd. So I'm looking at this diagonal here. We already got a minus 3x to the 3rd. To get rid of it and get 0 is plus 3x to the 3rd, which means up top here I have 3x squared I put in. And then I multiply it times this thing, so that gives me minus 9x squared. Then I ask myself, what plus minus 9x squared gives me 0? Well, that's 9x squared. And what goes up top? Plus 9x. 9x times that's a minus 27x, which means this has to be a positive 27x. And that means that's a 27 up top. And this row or column or whatever right here is a minus 3 times the 27. So that's a minus 81. No remainder. Guess what? It matched up perfectly again. Okay? But you should start noticing the things. We started off with x squared and a minus 9. Then we did one with x cubed, went to 3 and went to minus 27. Now x to the 4th, minus 81. So both keep getting bigger. There's a reason for that here. Okay, and there's a pattern developing here in the answer if you can catch it. And that's what we're going to be discussing for a couple days in this next lesson. So, moving on to a couple rules. All right, so I've got some notes here. I want you to squeeze the notes in the bottom of page 18. No, you don't have this all written out there, but in the future episodes it will be, so it's just a matter of writing them in. Basically, the first thing I want to know is that the expression x minus 3, okay, divides without a remainder. Okay, into all three dividends, meaning this part here, the last three examples, A, B, and C, which means if it goes in there nicely, it is a factor of each, and that's going to be critical, and we're going to talk a lot of that in the next chapter or so. Okay, so it's a factor of each dividend. The dividends are basically now, number 2, the difference of the power of x and power of 3. So for example, x cubed minus 27 is really x cubed, so x to the 3rd power minus, and 27 is 3 to the 3rd power. So they're both being cubed. X and the minus 3 are being cubed. Therefore, the degree of the quotient, so we can put the word degree in here, of the quotient, okay, is 1 less than the degree of the dividend. So I'll fill that in with a dividend here. All right, next, the terms of the quotient are basically your powers, okay? Basically the product, of the powers of x and 3. Okay, so of the powers of x and 3. Okay? The exponents of x decrease by 1, so they decrease by 1, and the exponents of 3 increase by 1. That's the rule. And then each term is going to be positive. These are the rules that we're going to talk about with an a minus b squared type situation. Okay, so just have those down. We're going to talk more of those in class because this is a higher level thinking that we're going to move into the process. So my final example here, we're going to squeeze this in as a D. It is not on your paper, so find a spot for it. But it goes right along with the others. We did, in the past examples, we did one with an x squared there, then an x cubed, then x to the 4th. I knocked this one up to x to the 5th. And this was powers as well of the 3rd. So if we're going to talk about this one here, this one really right here is, this part is really negative 3 to the 5th power. And you can check that out on your calculator and verify it. But that's where we're going. So we're going to go with an a minus b situation here. And the bottom line, if you go by your rules, we take a look at this exponent here. So the first one we're going to write is going to be an x to the 4th. This is going to be the answer without actually doing it. You could do it long division or reverse tabular. Okay, and then the next one is going to go down. So we're going to have a plus, and there's something x to the 3rd. And then we're going to have a plus something x to the 2nd. And then we're going to have a plus some x, okay? And that keeps going down, if you notice. I start off with 1 less than this, And I keep going down by 1. I'm all the way down to 1, and then I'm going to have 0 here. So 4, 3, 2, 1, and then none. At the same time, this guy here starts at 0 of those, and we're going to start introducing the 3's here, okay? So on this problem right here, I would actually put in, there would be 0 of those there, but then I'm going to put a 3 in here. And then 3 times 3 is a 9 right here. And then times 3 more is a 27. And then 3 more is going to be an 81. And that's our shortcut. You basically start off with your exponent 1 less than what you got here when you got an a minus b scenario. And of course our a minus b scenario in this case is the x minus 3. And we're talking about squares, okay? We're talking about square type thing. But our answer comes out of that. And like I said, I started with 1 less with 4, then 3, then 2, then 1, then none. And I start off with nothing on the 3's, then 1 3, then 2 3's multiplied together, 3 3's multiplied together, and 4 3's. And that's your pattern. So if you actually wanted to take it to another one, think about it. What would the answer be if you figure out like x to the 7th or something minus, and you'd have to figure out 2 more 3's multiplied times the 243. All right, anyways, that's enough to take in for now. We're going to talk a lot more in class about this, and we're going to stretch this out a bunch, all right? See you in class.